Hello? Live?
Yep.
Okay. Welcome, everybody. We see lots of people starting to check in. I see a few people from California. Today, we're going to talk sound API design with Mike Amundsen. And Mike is joining us via Google Hangout from Cleveland?
Cincinnati.
Sorry, Cincinnati.
Cincinnati.
Yeah, my bad.
The Cincinnati, home of the Cincinnati Bengals, the
Right.
Cincinnati Reds, the town that talks a lot about character building and fortitude, which is the euphemism for not winning the critical games.
Right. Cincinnati Reds, weren't they not just in the playoffs last week?
Yeah, they were in the playoffs. They're no longer in the playoffs.
No longer in the playoffs. Okay.
You're rubbing it in.
Okay. Well, good thing we're not talking baseball today. We're going to talk sound API design.
Cool.
So, I see lots of people still checking in. It takes a few minutes for people to get settled.
Sure.
So don't forget you can tweet your questions if if you don't necessarily have the time to sit and wait until your question gets answered. You can use the hashtag #Layer7Live. Obviously, you can chat in the stream. You can see the red button there, check in and chat. And if you need to go away from your desk or you've got a sort of a complicated question you wanted to ask Mike, you can always email that in at techtalk@layer7, and we'll make sure to get your question answered. So we appreciate everybody joining us this morning. And we anticipate lots of questions, and we're just really happy to have Mike here. This is your second one, I think, Mike.
Yeah, second, possibly third.
Possibly third.
Yeah.
It is your third, yeah, sorry. So 3-time lucky. And you know what else we're going to do? We're going to give away a Layer 7 t-shirt at the end of the show. We've got this cool JSON one. We've got a Where's WAddle t-shirt. We've got two other ones. I won't show them all. But at the end of the chat, we'll ask us a skill testing question, and you can tweet it, chat it, or email us your answer. And if you're right, then we'll send you a shirt. So, Mike, would you like to introduce sound API design?
Yeah, and actually, this title has kind of morphed over the last week. Actually, what I want to talk about is a solid foundation for API design. So the last couple times we've talked, I think we've talked about actually designing the API itself, and the guidance that we give our customers has a lot to do with treating it as a malleable interface, and using the same kind of things we use with user design for API design. But today I wanted to see if we could start to talk about the back end. Like, what does it really take to set the stage for this kind of malleable, evolvable API? So I wanted to talk about 4 things that we cover a lot in our guidance sessions, which are the notion of connectors are not components, the representation service, a caching service, and security layers. These are the things that I think really make a great foundation. So those are the 4 things I wanted to talk about and get people to kind of think about today.
Great. Okay. So are you ready for questions?
Sure, let's jump right in.
Okay, I see we've got a few people making some comments about the WAddle shirt on Twitter. And David, I know you've been here before, and I think I see Hussein who's been on the chat before. Appreciate that. So, don't hesitate to ask any questions you might have.
Absolutely.
So, first question from Mike. Why is it important to create a separation between what you call components and connectors? Aren't they really the same thing?
Yeah, so this is a great question, and this is one of the sort of the fundamental principles that we talk about. If you think about components, when I use the word components, I mean databases, file systems, your source code, queues. These are all components that actually make your system work. And those components are private. The database brand you use, the storage system you use on disk, the queuing management you use, nobody cares about that on the internet. It's sort of like on the internet, everybody, you can still be a dog and nobody cares. Nobody cares what's happening behind the scenes. So those need to be kept private. I shouldn't know that your object model uses this format, or that your object graph is using this format on storage. So that's components. We keep those private. And the way we make the information from components visible to the outside world is through these public connectors. So connectors could be things like an HTTP server or an XMPP server or IRC or SMTP or all these protocol standards that we know about. So this idea of components and connectors keeps us clean when we're on the internet, and it's a basic separation of concerns model. So what we give guidance in our APIs design workshops and boot camps are make sure that you build your component infrastructure completely agnostic of any connector information. So your components know database and they know whatever your source code is, and then you hand that off to this connector layer, and the connector layer will translate that into HTTP or FTP or WebSockets or whatever. So keeping those two separate is really important because you might end up serving multiple connectors for the same component architecture. Hopefully that helps.
Okay, great.
Yeah.
Don't forget, keep those questions coming in. Next one from Mike. I'm not sure. I'm not sure I understand the representation layer. Why do you need this?
Oh, okay, good. So, so I've already talked about this notion of component and connector. When we finally get to the connector layer, one of the great things about HTTP in particular, it's the only protocol that actually lets you decide how you want the data to be represented. When we do FTP, we just do file-to-file transfer, or when we do XMPP, everything's always in XML, so on and so forth. In HTTP, we have this feature where we can say, hey, can you give me the sales figures, but I'd like them in CSV format so I can load them into Excel. So I'm going to represent those sales figures from the component as a CSV response, or I might represent them as a JSON response for a handheld device, or an XML response for a desktop application, or an HTML response for a web browser, or maybe even just a pure graphic. Maybe I just send this out to some handheld as a pie chart. So that notion of representing the data is another separation of concern, another separate part. So if you keep those separated or devoid, then you might build an application that's just serving web pages, HTML. Somebody comes along and says, hey, we need handheld devices. I don't need to upset any of my component infrastructure or my connector piece. I just need to start representing those data differently. And I think that's really the importance of the representation layer or service.
Right, okay. Let's take a quick peek at Twitter. Wow, we see people all over the place. Austin, Texas, St. Petersburg, Florida, California. Don't forget to chat in your questions. You can tweet them. Hashtag is Layer7Live. You can definitely email us. Like I said, if you need to go, go away from your desk or whatever, email us your questions at techtalk@layer7, and we'll get those answered as well. Some of the other questions might spark questions that you may have. So we're going to hit Mike with his third question. Oh, sorry, here comes one in from Facebook. Mike, for the connector and representation layers services, what are the management techniques you suggest using? Are these separate app servers with their own internal MVC or 3-tier or others architectures? Sorry, I'm not reading that very well. Are these separate app servers with their own internal MVC or 3-tier architectures? Right. And specific examples?
Yeah, so usually not. You certainly can distribute these out and use some, OSI 7 protocol between them, but usually it's enough in a system to do this within your component architecture. So I might write some Java components, and then that talks to the Apache web server that's written in C, and that web server will use a representation which is really just maybe written in Python or Rails or something like that, and that representation service does its own work. So it's not necessary to actually treat each one of those as actually web services themselves. You can just treat them as separated components. But it is important to make them pluggable. So whatever your architecture, in Visual Studio you may have some idioms or patterns that make sense that might be different than if you're in JAX-RS or if you're working just in pure Python or Rails. But if you keep them separate, then you're going to be able to rearrange them however makes sense for the particular request. So most of the time they're not done as separate standalone servers.
Okay. So hopefully, Hussein, that answers your question. And as usual, don't be shy to chat in to follow up or any other
Yeah,
questions that you might have.
absolutely.
Um, let's see what we've got. Um, Mike, I've heard I've heard before. Sorry, it's not written.
You can do it.
I've heard before tell people. Maybe it's I've heard you tell
That's
people
probably right.
before that the API should be a thin layer above the components. Why is that?
Yeah, okay. So this is also a big part of the guidance model that we offer up. So in the way we see it, that API is actually the interface. So just as you would have a user interface, you could have lots of UIs that you want to present to different clients. You may even want to A/B test them to see which ones work well and which ones don't. So we actually encourage treating APIs the same way. You want to use the same techniques for writing an API that's very thin, that really is sort of the server-side mashup of whatever component architecture you have. And that makes it easy for you to be agile with that API, to present new API calls, to present new representations. Very often we actually say things like, usually your components are compiled, but your API layer is scripted. So you might script that in Rails or Python or something like that. So it's a nice thin layer, and it gives you the ability to modify that at a relatively low cost. The Q&A work is not so high because it doesn't touch as many parts, and you usually can deploy that relatively quickly and easily too. So keeping it thin kind of improves your ability to move quickly on that part, and that's the part that everybody sees.
Okay. Another question through the stream from Nandakanti, it looks like. Sorry if I butchered your name. Nandakanti Ravi says, I'm not a developer, I'm an administrator or engineer. Do I have to learn programming to design APIs?
The short answer is no. Right? You don't have to be a programmer to design a good interface, whether that's for humans or machines. You're probably going to need, that same kind of cooperation and assistance with people who know how to implement that design in a credible way. Just like you work with any UI designer, right? I don't need to be, good in Adobe and CSS and all these other things in order to help design a good interface. But no, you don't need to be a programmer. You just need to have those same sort of principles about what works and what doesn't. And of course, a big part of any good design is iteration, right? Feedback. So you put a design up and you test it. You test it rigorously, and you get feedback that says, hey, this kind of stinks, and you change it, you modify it. And of course, that's not programming either, right? That's a lot of social stuff. We tell people, especially in this web space, a great place to do testing and get great feedback from really passionate people are hackathons or codathons. Get your API out there where people can work on it and test on it, and they'll give you lots of great ideas on it.
Okay. Got two kind of in the queue. Natakanti sort of follows up, and then Terry will get to your question. How do you develop design? How to develop design skills? Any online sites? This is Natakanti asking the follow-up question.
Yeah.
How do you develop those design skills?
Yeah, that's a really good question. So I have to tell you, there aren't any really good methodologies or reference materials on this idea of API design itself right now. In other words, this notion of general design. There are a couple of points of view. So some of the design models focus on designing URIs and payloads to match. So that design model is very much sort of the RPC or object-oriented HTTP, and there are a couple of good books on that and several good sites. I actually wrote a book on hypermedia style design of APIs, which I think we probably have some copies of somewhere sitting around. And that's a sort of a different book. So that's actually, building hypermedia APIs or something like that. So there aren't any good places now, but I can tell you, in the work we're doing to try to create some guidance, we're studying a lot of human-computer interaction, or HCI, texts. So we're working with books by people like Donald Norman, who designed user interface theory, and he has all sorts of things about life cycle of interaction and so on and so forth. And that stuff will help. So if you get well versed in the notion of the way interfaces work in general, how a thing to a person works, that's what we're using right now to help build our design guidance.
Okay. I've got, looks like 3 questions, sort of 3 or 4 questions in the queue. Howard, and unfortunately, Mike, I'm only going to be able to ask this to you. I'm not going to be able to chat this through. So, are connectors and gateways effectively the same? So maybe answer that one, and then Howard's got a sort of follow-up question to that.
Okay. Well, connectors and gateways can be the same. Yes. So you can definitely have a proxy is like a connector, right? Because that really speaks in sort of a general language. So if you have a security proxy or a caching proxy, those can be seen as connectors. So a gateway like a security gateway or something like that can definitely be seen as a connector because they speak in sort of the general terms of the shared understanding on the network itself. So I think that's probably right. Yes, I would think of gateways as connectors.
Okay, and then Howard asks, secondly, do you have a reference architecture model we can use to get a better understanding of this?
Yeah, so we have not published an architecture model at this point. This 4-stage model that I'm talking about is what we're working with now, and what we're doing actually is discussing this with a handful of customers that we have today and comparing it against some successful implementations that we know. So we'll actually probably publish some written materials here before the year is out. And this is, again, sort of a chance for us to talk about it right here. But right now, we don't have a document or a diagram online that lists this.
All right, the chat's been blowing up a little bit.
Yeah, sorry, the chat's been blowing up. I'm just getting behind organizing my questions.
Okay.
So anybody who's asked a question who hasn't got an answer yet, please just be patient. I'm trying to organize them here quickly so we don't get behind. I've got a couple questions from Terry. Howard, I think we answered yours. If not, maybe just chat in quickly again. And then Ryan, through the live stream chat, asks, any tips on how to document your API? Full documentation should include syntax examples, in brackets, sometimes in many languages, some responses, use case examples, narrative descriptions, etc. Where does all this go? And how do we keep it up to date? So that's a good question.
Yeah, it's a really good question. So here are the parts that we tell people when they publish an API, they want to make sure they have. You want some kind of narrative, human readable documentation, right, that sort of explains things. You want some examples. What we tell people is you should make it as easy as possible. I should be able to have like a sandbox where I can just kind of paste something in and get results back right away. So you want some kind of sandboxy bit. You want some examples. You could describe, this is the URL you call, you send this information, you get this information back. You want to give people examples of that. You might actually want sample applications that people can download in a particular language. What we encourage people to do is provide examples, like full-blown examples. Don't focus too much on SDKs because they're sort of a secondary step, and then someone needs to write code using the SDK. A company called Twilio, who is having an event this week, TwilioCon, they do a great job at this. Just visiting their site alone will give you some really good ideas. One of Twilio's rules of thumb on their site is you should be able to get from API key to your own working code in 5 minutes or less. So making it very easy for people to find this. So all of this idea of documentation, samples, sandbox, maybe hosting some example apps, really can end up in one place. It includes some forums and some discussion pieces. And it turns out that this is basically a portal. This is a sort of a developer portal. Layer 7 has a great API portal system. They even have an API portal system that's hosted, and they have one that's a service called Appify, which you might want to check out as well. So caveat emptor, of course, this is a Layer 7 product, but there are other examples of this as well.
Okay. I just don't want to miss another question here. I'm going to get to Terry Yoder's question.
Okay.
Please give us your take on versioning an API. Specifically, how do you represent version numbers in URLs?
Right. So, short answer, our take on versioning on URIs is don't do it. So, to think about that a little bit further, versioning is a technique, and that technique is usually to prevent some kind of collision or miscommunication between client and server. There are lots of ways to prevent that, and versioning is just one of them. Versioning works when you own the source code and you have SDKs, because those are very tightly coupled pieces. But when you're on the web, versioning is not, versioning as we think of it, is not really as necessary or needed. I know a lot of people duplicate that into the URI space or into the header space. We tell people not to worry much about that. I can still call up HTML documents that were written 10 years ago, even though they're slightly different, because the client's been written to support that. So we tell people in general, don't do it. If you must, basically version is a way to break your existing apps, right? Because your existing apps aren't going to work anymore when you change versions. So if you must break your apps, change the URL. Sometimes that changing URL means you've got a version 2 or a v2 somewhere in it. If you think about your URL space, it's huge. You probably have hundreds and hundreds. I work with a company that has 700 URIs. So when that happens, if you add v1 to everything, you've just broken 700 calls. And you probably don't need to break 700 calls. You probably only need to change a couple. So if you're going to do that, just change the URLs that are specific, and I think you'll be fine. You guys are getting a little blurry for me, so I don't know. Am I looking okay?
Yeah, you look good on our end.
All right.
We've got lots of questions in the queue. And
maybe my answer should be shorter.
No, it's just it's a very good topic, and there's lots of questions around it, and they're coming in 3 different forms. So I don't want to miss anybody. Looks like
Got Todd, G Todd.
yeah, G Todd. Question about WAddle. How mature is WAddle to get published, just as WAddle is? Can you provide a reference site that the latest conventions are presented?
So the question is, how mature is WAddle? Is this sort of in comparison to WAddle? So it's certainly not as mature as WAddle, because WAddle's been around for more than a decade. But WAddle is definitely a solid standard, a solid built standard. I'm not sure if WAddle has an RFC. Somebody else can chime in if the IETF actually has an RFC on it. They might. And if they do, that's the one I would always use. So think about WAddle this way. WAddle is a way of creating a static description of the entire interface, right? So it's a bit like the standard ORBs or COMs or any IDL language, right? It doesn't tell you what order to execute these in. Doesn't tell you if these are, what security and so on and so forth. But at least it gives you a full set. So WAddle is good if you're using this RPC style HTTP, where you craft your URLs and you associate bodies to it. I know our hosting tools, our API management tools, import WAddle and create interfaces for that, create the lists, and that works fine. And that's a pretty stable system. While we're talking about some other things, maybe we'll take a look and see if we can find if there's an RFC on it. But it's more than stable enough to use, and I know lots of our clients use it right now.
Okay, great. Freudian slip, a Twitter question. I know you've been waiting. Let's see. Do you need to code the thin layer of an API, or can you use something like a Layer 7 gateway to do that light lifting?
Oh, so the question is, do you need to code the API, or can you do that at a transformation proxy, right? And Layer 7 has a transformation proxy. As a matter of fact, you can definitely do this at the transformation proxy. I did a demo app using our transformation tools where we had a SOAP service on the back end, and we had a client that wanted a JSON-based hypermedia style response. So we were able to do a transformation through one XSLT directly on the response out through JSON hypermedia. So it's actually very easy to do, and sometimes it's the great way to start. If you've already committed to this notion of a transformation proxy, then you can leverage that for lots of very lightweight testing. So you can actually treat that as sort of your A/B model or as sort of your proof of concept before you make any investment in some other heavy QA that might require, creating some scripts and some other things. So as a matter of fact, I know people do this quite frequently. Sometimes it's referred to as shaping, and that can happen both on the way in and on the way out. That's like a very effective way to test out and design APIs.
Okay, great.
By the way,
Looks like
a follow up. I'm sorry to interrupt. I wanted to follow up. There is actually a URL for the WAddle spec, and it's actually not through IETF, but it's through the W3C. So if you just Google W3C and WAddle, you'll get to the spec, and that's a recommendation. I think as of 2009. So that's very stable. So that should follow up on that other question.
okay. And anybody in the live stream chat, I can see Daryl Miller has shared an IETF link to WAddle. Looks like.
Oh, great! Very cool. So there is an IETF as well.
Yeah. And thanks for that. Thanks for all the participation. And I'm going to try to get to the questions that I've missed. And sorry if I've missed anybody. By the end of it, I should get to all the questions. Hussein, I know for sure that one of your questions got cut off at the bottom, so I'm going to ask it best I can. And there's a new one from ZHE. So quickly, I'll ask your question. Is the interface of API equal to service? If so, why do we start to use API terms instead of service? Why has that changed?
So is the interface of the API the equivalent of a service? And if so, why are we just change names? Is that right? I got that?
Yes.
Yeah. So you could think of it as a service. I tend to think of services a little bit differently. So I think of services as the component infrastructure, and I think of the APIs as the interface to that component infrastructure. So service is a kind of a multivariant term. You could definitely think of it that way. If you move to sort of the SOA experience, where we think of exposing services as endpoints, so you might think of that as the interface, right? So you might think that this is pretty similar. We in our guidance, we tend to try to encourage people to think of exposing the API itself, and that API could be a wide layer rather than a very thin, long layer. So usually service endpoints, there's a single entry and there's a long list of things you can do. So that's sort of the UI model. The UI model is go here and find the menu of possible items. What we often tell people to do is to think about creating APIs that are wide and thin. So you say, here's a lot of possibilities, pick the one you want. You could sort of think of the difference between a menu at a fast food place is sort of wide and thin, and a recipe for creating your own food is sort of long and narrow, right? Like you start here and you do this, and then you do this and you do this. So we tend to get people to think about doing this in a wide format. So that may be where the lingo sounds a little bit different.
Okay. Like I said, I've got a question from Rajesh Sharma. You've been waiting. Hussein, you're going to be after that. And David, thanks for sharing that link to the W3 WAddle, and he's got a question about REST, and we'll get to you after those two, if that's okay. Cool. So, Rajesh asks, in terms of APIs, do you see the elimination of the SOA gateway pattern, an externalized API, if we start to move the same functionality in advanced firewalls, or even, sorry, the end of it is cut off.
Here.
Pardon?
It's on the other window there.
Where? Oh, I see. Right.
So I'm not sure if I get this. He may ask again. So do I see the elimination of the SOA gateway pattern? So I think that refers to the example I was talking about earlier, where it's sort of an endpoint model, where you sort of go in through a doorway, and now there are lots of possible things that you can do. There's certainly no end to it. We have lots of customers that continue to use the SOAP model or the SOA service pattern very effectively. Sometimes you're even required to do so because of partners. So I don't think that's going away. One of the things that we emphasize in our guidance pattern is this is not a choice of one or the other. What you want to do is actually become knowledgeable and as best you can fluent in more than one architectural style. So we have customers that use the sort of SOAP-inspired SOA pattern. We have customers who use this RPC, HTTP, sort of what we sometimes call the CRUD pattern. And we've got customers that use this REST hypermedia pattern as a way to actually interface with the outside world. So I don't think these things are going away, but I think what we may find is a sort of a more careful application. Like this SOA pattern, this gateway model, is what our clients need. That's why we're using it. It's the most effective. This client over here needs more of a hypermedia evolvable interface. We're going to use that over there. So helping people to actually treat those as equal parties and find the right mix is the way we talk about it.
Okay. And also, because your question was cut off a little bit at the end, if you have more specific things, just make sure to chat them in, Rajesh, and Mike will be able to answer it in more specific terms.
Yep.
So, I said I was going to get to Hussein next. Where is his question gone? Sorry, guys. 2 seconds. Thoughts on how to document your API during design time?
How to document your API during design time. So this is actually so there's a couple of ways I'll approach this. Very often we encourage people to create a very thin API, even if that API just says OK back, right? It's really simple. So you sort of start your documentation sort of right out of the gate. There are a couple of cool tools that actually generate a documentation from either metadata like WAddle or WAddle, or they might even be able to generate documentation from the code itself. So I know some people who actually have a build process, whereas when they check in their code, there's actually a hook that then runs this auto-generated doc step. So if you do that and you use these auto-generated models, what you'll end up with pretty good documentation for signature to signature, but you're not going to get the actual narrative or prose, right? So in the design phase, very often that design phase might be code, but if it's totally outside, if you're actually doing this before you even do code at all, what we tell people to do is actually document the interactive experience. So we use standard things like stories, actor models, whatever sort of fits your community, and use those to actually be the documentation for that interface. So very often, if you're a team that's starting from the interface and working inward, the actual build early on, the design early on, will become the documentation that you'll pass off to developers, and that matches that public interface. So hopefully that gives you some ideas. If not, you can give me a follow-up to you.
Sure, thanks. Yeah, and Hussein, I know you're always a friend to Tech Talk, so make sure that just chat it in again. Like I said, it sort of went down to the bottom of the stream, and I cut off the bottom of your question. But hopefully Mike answered it. But again, and if it's more complicated, feel free to email it to Tech Talk at Layer 7 Live.
Yep.
No. Tech Talk at layer7.com. Sorry. I get the hashtag and the email mixed up all the time. The hashtag is #Layer7Live. Email techtalk at Layer7. So I definitely have 3 more questions that in the queue. David, you've been waiting patiently, and you're always a good friend at Tech Talk, so I appreciate that. Mike, can you touch on REST's optional code-on-demand constraint in a world of heterogeneous clients?
Yes. Oh, that's a cool question. So, talking about code on demand in a world of heterogeneous clients. So, the code on demand feature of REST, if you really look at the design pattern, is sort of the escape hatch, right? So, the REST model is very, very constrained. It's a highly constrained interface to try to make it easy for as many people as possible to participate. And when those constraints are so great that you can't get done what you need to get done, either because of latency time or just functionality. There's this notion that you're just going to ship code to the client and tell the client to go ahead and execute the code. That's that optional code on demand model. The problem we're facing now today is if I have lots of native clients, whether it's an Objective-C or it's written in Java, just running on an Android, running on a desktop, I can't always be guaranteed that there's a way to run code on demand at every one of those clients. So more and more, what I'm seeing are people designing APIs that don't require code on demand. In other words, you design interfaces that have all of the features necessary to get the work done without having to rely on code running on the client. So the way to compare this would be if you write an interface for an Objective-C app, you actually write all of the details in every response so that the actual code in Objective-C knows what to do and how to use it. So whether you do that as a sort of tightly coupled RPC model, or you use a more general hypermedia model where the client actually understands links and forms, you actually make all of that code run in Objective-C. Whereas you think about the way Google treats Gmail and a lot of its tools, I mean, they're all code on demand, right? There's a little div at the top and the bottom or something. There's a little container of HTML, and the rest of it is all just code that's running. So you have these sort of two different ends, and I'm seeing more and more people moving away from the code on demand, writing APIs and programming interfaces that don't rely on shipping code around. And I actually think that's a smart trend going forward, because I still see an awful lot of native apps in our future. And those native apps means it's hard to count on executable code that you might ship to the client.
Great. I definitely have two more questions in the queue. We're sort of getting around towards the end. Technically we've got Mike for another few minutes, so if you do have any follow-up questions or he hasn't answered anything you were thinking about, just be sure to chat them through Facebook, the live stream chat window, or hashtag @Layer7Live. Pizza, is that your real name? Asks, what is the difference between Service Programming Interface, SPI, and API?
Service Programming Interface and API. Actually, I have to tell you, I'm not familiar with that term. So I really can't tell. I hate to do this, but maybe the questioner can add a little bit more to describe the service programming model rather than me sort of like invent an answer.
Sure.
So maybe if you could repost, I'd be happy to do that. And if it turns out we run out of time, definitely send an email and I can do a follow-up. I'm sorry about that.
No problem. Luke Stokes asks, related to that, this is going back a few minutes now, but related to that, some hypermedia APIs aren't mature enough for mass adoption. What are your thoughts on quick to market versus pushing new standards forward?
Okay, so I think the second part is really the important one, like the difference between quick to market and pushing a standard. So to use hypermedia as an example, hypermedia is really designed for this sort of long experience. Like this is a client that has to last years and that has to be able to change and still function years later, right? A lot of us in our daily work, we don't care about years from now, we care about right now, right? So most of the tooling and most of the coding paradigms that those of us are familiar with today that are available to us are not hypermedia. They're RPC style. There I have a function and I have some arguments and you pass that and then you get that back. So if you're in a hurry, the better strategy right now is to use RPC. Now that probably means that a year from now or 2 years from now, you're going to have to do this again, because you're going to have to evolve some things, and RPC is difficult to evolve. But if the primary function is early to market now, if you need to get into some space and stay there, then we encourage people to continue to use that RPC pattern, because that's going to get you there fast. And I think another part of this, and this may be also what Luke is referring to, is if I need to get a lot of other third-party developers involved, it's probably not to my advantage to try to teach them a new way to develop. Hypermedia development takes some new techniques and some new patterns, and if it turns out I need to be quick to market and I've got a competitor that's easy and that's using existing patterns and paradigms like RPC, I might lose. So it may be really important for me to stick with things that people know at this point, and maybe even treat this as sort of a stalking horse, get that up, get that running, and I might still work on my evolvable piece on the other side. But quick to market right now still means using RPC for the most part.
Okay, Pizza followed up on his question.
Good.
He actually meant service provider interface rather than service programming interface. Does service provider interface help?
I'm going to take a shot, and he can follow up again. So by service provider, I guess you mean sort of like a generic or a standard pattern. I have a service provider. I guess this interface has to do with maybe software as a service or something. What we tend to tell people in general, and again, if this doesn't hit, Pizza, you can go ahead and post again, that we think the interface ought to be very specific for the task that you're solving. That's why we tell people to use a very thin interface. When we tell people to design an interface, we say focus on the task at hand, focus on the users. Don't focus on the objects or the devices or the storage pieces that you have in the back end. Focus specifically on what you want to accomplish. You can write lots and lots of different interfaces against the same set of components. And the better that interface, the more intuitive it's going to be for developers, more intuitive it's going to be for people to build applications against. So I think that may be what he's talking about. Service provider interfaces very often focus on the back-end services. I have machines, I have disks, I have data, I have customers, I have so on and so forth, and they have an interface that's based on that. We encourage folks to actually create an interface based on the work that they're going to do and use that component infrastructure internally. So hopefully that helps. If not, follow up and we'll keep going. Okay,
how you doing, Mike?
Yeah, I got some more time.
Okay, I think we have time for one more question, and we've got one from Terry Yoder coming in through Facebook. Cool. So what are the expectations of most clients as far as uptime, reliability? If our API is hosted inside our walls, not in the cloud, is that reasonable for most folks? What are other API providers doing?
Okay, so there's a couple of things. I'm not sure that this has changed much. It's been a couple of years since I actually read any sort of usability on reaction time, but I'm pretty sure you've got about 1 or 2 seconds. I think you got about 1 second before users start to worry, and I think you got about maybe 2 or 3 seconds before they start to decide that this is broken, and about 5 seconds before they give up. So we usually, I remember that we used to say, if I can't solve the problem in like 2 seconds, I need to tell the user to hold on, and if they can't solve it in 5 seconds, that's a fail. That's going to be the case whether you're hosting it internally or on the cloud. Now, so what we're now talking about is latency. There's latency in lots and lots of places. So if you're hosting in the cloud, but you have some data somewhere else, that like you may have some captured data on your local servers, so now you've introduced latency there, right? If you're hosting on the cloud, but you're talking to another service like Twitter or Facebook or something else, that's another place. There's latency there. So you got to manage a lot of those latency pieces. So to solve that particular problem, I see a lot of people going to this node-style coding architecture where you actually run a lot of parallel requests and you treat the coding asynchronous. So C# and Java and Node and even in Python, and I think even in Rails, you can do this asynchronous model. It's sometimes called the reactor pattern. And I see more people doing that because what's happening is more and more pieces to solve a particular request are remote, and that adds, even when you start adding 20, 50 milliseconds of latency, that adds up. So the biggest thing is not necessarily where it's located, but the coding pattern you're using for communicating with these various parts. And I see a lot of people using this asynchronous or reactor pattern for that.
Okay. I don't think we actually have any other questions. I see there's a couple of comments. I'll just read them out if you don't mind.
Sure.
Daryl Miller comments, directed at pizza. Reusability can be achieved via media types and link relations rather than standardized APIs. And then, yeah, and then Steel Price comments there. Nice nickname, by the way. Links are still an issue. COD doesn't actually mean the same code for all clients, but links seem to, and there's no common STD. We have HAL, RDFA, JSON-LD, JSON plus collection, but none used consistently.
That's definitely true. There is we're in a disruptive period in this space, so there are lots of creative people doing lots of creative things. I have to tell you that in the last couple of years, I've really seen a lot of people take an interest in the HAL message model, the HAL media type. HAL is both an XML and a JSON pattern. Some pretty notable companies in the U.S. are using it, and I think it's worth a good look. And I think, we're going to have to make some decisions here. And there are a couple of other contenders for that sort of space. But it's important. That's why we actually emphasize this notion of that representation service in our design model. So you might end up being able to represent in HAL. If it turns out a year from now, HAL is not the winner and there's somebody else, you can represent in Atom, represent in Collection JSON, represent in Siren. There are a handful of possibilities out there. Make that a cheap bet. Right? Don't bet the farm on your entire system. Treat that as a component, and you'll be a lot better off.
Okay. Definitely the last question, and then we're going to give away the shirts.
Cool.
We're running up against the clock.
Okay.
But Mike, you're doing a great job. Lots of questions, and it's very difficult for the speaker too because you have no idea what the question is going to be. So you're thinking on your feet, and I really appreciate it. Good job. We've got lots of great questions. So we really appreciate the audience participating and commenting. It's been a really good dialogue. And Daryl Miller asks, any hints on designing media types that can evolve but maintain backward compatibility? Final question.
Yeah. So if you're working in the space where you're actually focusing your domain problem in the message, right? That's media type design. That's voice XML, Atom, HTML, these kinds of things. The real key is to create a media type that is general enough to encapsulate your problems, but not so specific as soon as there are changes in your problem domain that the system kind of breaks down. So it's this sort of angle from specificity to generality that can kind of bite you. So what we tell folks is literally to test, like, because we tell people to start from tasks and things to do, how do you represent the information, the state that you're going to transfer both in and out in this message? And you actually get to tweak the message. The other thing that we tell people just in mechanical terms, the way you prevent versioning is to make sure that you do things like extension, like you design both your message, your server, and even your client to recognize new data elements when they appear. Usually that means you have data collections. You don't have just named items, or you have a data bucket in the message, and the clients can look for that. So you always add, you never take away, and you never redefine. And for the most part, you can handle just about every possible change in your domain model with those simple rules. Never take away, always add, never redefine are the three big ones.
Great. So if you do have questions that we didn't get a chance to answer, you definitely tweet them using the hashtag Layer7Live. You can post them on our Facebook wall. You can email them to techtalk@layer7. And we'll follow up with Mike and make sure he answers those questions as well. But thanks again to everybody. We really appreciate everybody joining us today and asking such great questions. And Mike, to you, thanks so much. Great job.
Had fun.
This has been one of the most successful Tech Talks we've had, I think, in terms of questions and interaction and discussion. So that's really good.
Yeah.
Shirt time. So we've got a Where's WAddle. We've got this great JSON. That would go. Here it is. JSON shirt. We've also got Layer 7 Better Than the Rest. And simply, what is the most popular API on the web these days? And again, post the answer on our Facebook wall or tweet it to Layer 7 or use the hashtag at Layer 7 Live. Just get us the answer and we'll send you a t-shirt. Thanks everybody, and thanks Mike.
Thanks.
And stay tuned to our Twitter and our Facebook and social media in general for the next upcoming Tech Talk, which should be in a few weeks' time. So thanks everybody.
Take care.
Thanks Mike. Thanks Jose.
Thank you, Jose. Take care, guys.
Thank you.